Now we're going to cover some basic inheritance concepts. First thing I'd like to do is to take a look at the rectangle class that I've already created. Notice it has private data for length and width, public then data for get length, get width. I have created a set data function that takes in length and width and assigns it to the private data. Additionally, I have a show rectangle function that will show the dimensions of length and width, and a calculate function that will calculate and display the area. We're going to use this as our initial base or parent class. Now I'm going to create a child or a derived class. I'm going to call this one block. Now, because it is a child, we have to say where it inherits from. The parent then is going to be a public inheritance, and the name of the parent is rectangle. We're going to have some private data. Of height and public functions. We're going to do a set data and it's going to have to set the length, the width, and the height. The first thing you're going to notice is that there's only one field for the block class called height. But because it inherits from rectangle, it actually does have these two fields as well. So you'll notice I call this set data function that will take in the length, the width, and the height. However, length and width are private. So because they're private, the only way I can set them is to use my parent's set data function. But if you'll notice, I have a set data too. So in order to tell it to use the parent's instead of my own, is we have to tell it it's the rectangle class using the scope resolution operator. So now we're saying, hey, let's call my parents. Send it the length and send it the width. And then lastly, I can assign my own height. This is going to allow us to call our parents' set data function. Without this, it would have tried to call itself. And this would have just kept going back and forth, and then you would have been in this recursive loop. Next, I want to be able to have a calculate function, similar to my parents' calculate function. But I can't just use my parents because it only calculates the area. If I'm a block, I have an additional field that I have to calculate. So let's see if we can create another calculate function. In this calculate function, I'm going to have to calculate the area. Actually, we probably should call it volume. Length times width times height. Okay, it's very similar to our parents. Now you'll notice that I'm trying to access the length and access the width. Do you think I'm able to do this? Let's try. I'm getting an error that says length is private, width is private. Of course, they're my parents' private data. I don't have access to them. Even though I'm a child, I still don't have access to my parents' private data. So I have to go ahead and use the gets. So if I change this to use the getLength function and the getWidth function, I should then be able to compile if I spell this correctly. There we go. Let's go ahead and throw in a main. And then we'll compile. Okay, this compiles okay. So we have our setData function, we have our calculate function. We're going to do a show function as well, but this time we're going to call it showBlock. And its job is basically to show all the dimensions. Now we notice we have a showRectangle from our parent that already shows the length and width. So we're going to go ahead and call that. And then we're going to follow with our own cout. Now one thing I want to pay attention to is, did you notice here in our setData function, we had to tell it to use our parents, but down here I didn't. The reason I didn't have to do it here is because I don't have one. So as long as I don't have one, I can just tell it to use my parents. Here, I have one and my parents have one. This is why I had to tell it which one we're going to use if there are two. Again, this is called overriding. Okay. So let's go ahead and compile. Save first. Go ahead and compile. No errors, no warnings. Fabulous. Now I'm going to go ahead and actually create some objects. First, let's try creating a parent object. Rectangle. I'm going to call it shape. And I'm going to set my data. And 4, 5. And then I'm going to call a function to show the rectangle. And then I'm going to call my shape function to calculate. So let's go ahead and run this. If I take a look at our output window, you'll notice my dimensions are 4 by 5, my area is 20. So show rectangle actually shows the dimensions, and then calculate shows the area. Great. Let's do the same thing, this time for our block. We're going to set the data. We're going to take our cube and show. And we're going to take our cube and calculate. Let's go ahead and run this, save it, compile it, and run it. And this time, dimensions are 4 by 5, area is 20. That was for my original rectangle called shape. Now notice it says dimensions are 4 by 5 by 3. Notice it's the same 4 by 5. I added the by 3. Now the volume is 60. Now I want to take it one step further. Let's go back up to our parent. And let's assume that our parent has a constructor that requires data. So it will then assign for length and width, like so. Because it's a non-default constructor, we have to go down here and instead we're going to comment this line out, and instead we're going to give it the data right here. So now we should be able to compile and run it. But watch what happens. We don't get an error here. Instead, we get an error on our block. The main error that you're going to see is there's no matching function call for rectangle as a default. What happens here is when I go to create a child class, such as cube, it actually attempts to create the parent first. So because it's creating the parent first, it's coming up here and it's required data. If you don't have a default constructor in your parent, then you're going to also have to create a non-default constructor in your child. And you're going to have to take in that exact same data. We've done this before. How do I tell it to call my constructor? Do you remember having to do this? That was using an initialization list. This is one of the reasons for using an initialization list. When we have a parent where we have a non-default constructor, we're going to have to call that constructor first, giving it length and width. So while we're here, we might as well just give it height as well. Tell it to assign the height for our child. So if I come down here, again, we're not going to call this, but now we have to call it giving it all three things, 4, 5, 3, same data. Let's save it, compile, run it, and you will see dimensions are 4 by 5, area is 20. Dimensions are 4 by 5 by 3, volume is 60. Let me go back and show you that code again and have you understand that we have to use this initialization list right here when a child has a parent and the parent does not have a default, meaning it has a constructor, a non-default constructor that we have to call. We're going to have to do it this way. Okay, so I hope this helped, and we will talk to you soon.